Hello everyone, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today in the lecture, we are going to see about the case study of the design principles of Linux operating system. Let's get started. So as we have previously known in the previous lectures, the concept of Linux design principles and about Linux kernel modules. So in the previous lecture itself, I have told you what is Linux. So Linux is a free open source monolithic kernel operating system. Monolithic kernel means the user space as well as the kernel space both will operate in the same address space. So Linux is a multitasking operating system which is derived from the Unix operating system. So by multi-user it means that many users who are in different computers or multiple terminals will be interacting with one single computer system which is having a network. So Linux is an example for a multi-user multitasking operating system, and its design principles are mostly based on the unique design. So if you see a file system, it follows a traditional Unix semantics, and if you see the networking model is also implemented using Linux. It implements the standard Unix networking model, and the main design principles of Linux follows three important design goals, namely speed, efficiency and standardization. In order to achieve efficiency and standardization, it tries to adhere to the POSIX standards. We know POSIX stands for Portable Operating System Interface. So in order to provide for standardization, at least two of the Linux distributions have already achieved the POSIX certification. So we know that in POSIX standards there are set of specifications which specifies different aspects of operating system behavior. We have POSIX documents for common operating system functionality, as well as we have POSIX documents for process threads. We have POSIX documents for various real-time operations. So all these standards are being followed by Linux distributions, and Linux operating system supports 6 POSIX threads as well as POSIX real-time process control. So all this is being done in order to ensure standardization in the Linux operating system. Now, if we see the components of the Linux system, it is being shown in the screen. The components of the Linux system can be divided into three categories. At the bottommost level, we have the Linux kernel and the loadable kernel modules, and the middle layer consists of the system libraries, and above the layer of system libraries, we have the system utilities, as well the system management programs, as well as the user processes. So we can say that Linux process is composed of three main bodies, namely the kernel system, the libraries and the system utilities. So we'll be seeing about each of them in detail. So the first one is the kernel. So this is responsible for maintaining all the important abstractions of the operating system. By abstraction, we mean anything like it can be the virtual memory concept or the process concept. Every abstraction of the operating system is maintained by the Linux kernel. And when the kernel code executes, it is set to execute in a particular type of mode called the kernel mode, or it's also called the privileged mode. So when kernel code operates in the privileged mode, it actually has full access to all the hardware components of the computer system. And apart from that, we already know that Linux kernel is a monolithic kernel, which means that the user space as well as the kernel space both will reside in the same address space. And whenever there is a switch from user space to the kernel space, it is implemented to the concept of system calls. So when we have the monolithic kernel, it means that all of the kernel code as well as the kernel data structures for implementing everything is to be present in the same, it is going to be in the same address space. For example, if we may have the code for implementing the file system, we may implement the device drivers. We will have the code for implementing networking, or we may have the code for implementing virtual memory or scheduling. All such types of code are going to reside in the same single address space. That is the concept of monolithic kernel. So the next layer is our system libraries. Just recall the diagram for the components of the Linux system. We can see that the system libraries is the middle layer, which is in between the system management programs or the user utility programs and the Linux kernel. So the system library provides a standard set of functions through which the application programs or the user processes can communicate with the Linux kernel.